Hi folks, we're going to take a look at number 18 on page 83. So they want us to find the a value such that this line is tangent to this curve at x equals -2. All right, so first of all, let's recall what it means to be tangent to a curve. So that means that this line and this curve have to share a point, and the slope of this line represents the rate of change of this curve at that point. But of course, now we know that the rate of change can also be determined by finding the derivative. So that means the slope of this line is the derivative of that function at x equals -2. All right, so let's start by finding the slope of this line. Obviously, we're going to have this, this unknown a in there, but we expect that. So bring the -4y to the other side. So we have 4y is equal to what do we have here? So ax plus 21. So that means that y is equal to a over 4x plus 21 over 4. All right, so the slope here is a over 4. Sorry, that should have been x. There we go. So now let's find the derivative of this function at x equals -2. And so that means, we know that that slope is going to have to be equal to a over 4. So let's see what happens here. So first of all, it might be a good idea to rewrite the function as a times x to the -2 so that taking the derivative is easier. So if I take the derivative here, so a is just a constant. So I can just do a times the derivative of x to the -2, which is just -2. X to the -2 minus 1 is -3. And so what we're looking for is y prime at 2. All right, so we just have to input 2 here. So in the numerator, we're just left with a -2a. And then in the denominator, we have, oh, sorry, that should have been -2, -2 cubed. And so we have -2a over -8. And we end up with a over 4. You might sort of say, well, okay, that's odd. Hey, we just get the exact same value there. So that means this line already has, incorporated into it the correct slope, but that's not going to help us find what the a value is. But remember, being tangent to a curve doesn't just mean that the slope of the line is equal to the derivative of the curve at that point. They also have to share the point. Okay, so that means what we can do is use the fact that the value of y of the function at x equals -2 should be equal to the value of y when x equals -2 for this curve. All right, so this is how we're actually going to solve the problem. It's not going to be the derivative that's going to help us out this time. It's going to be the fact that this line and this curve have to share a point at x equals -2. All right, so we already have this here for the curve. So at -2, we have that y is equal to a over 4 times -2 plus 21 over 4. So we have an expression for the y value. This simplifies a little. So what do we have? We have, this is just going to be 2 and 1. So we have -a over 2 plus 21 over 4. And then if we take the y value of the parabola, what do we have? We just have a over -2 squared, which is equal to a over 4. And so now we're just going to equate these two y values since they have to be shared by both the line and the curve. So we'll do that up here. So what do we have? We have -a over 2 plus 21 over 4 has to be equal to a over 4. And to make life easier, I'm just going to multiply both sides by 4. So this I'm going to be left with -2a plus 21 equals a. So I'll bring the -2a to the other side. I have 21 equals a plus 2a is 3a. And so a has to be equal to 7. Okay, and there you have it. We've solved the problem. So just to recap, this is not a particularly difficult question. It's just not being solved in the way we might have anticipated, because we tend to always use the derivative to solve these types of problems. So when we tried to do that, and we said, hey, the slope of the tangent has to be equal to the derivative of this function at x equals -2. We just got that, well, both were equal to a over 4, which is great. They're both the same, but it doesn't help us solve for a. So that's where we had to use the other condition on being a tangent to a curve, as they also have to share a point at that x value. So we knew that the y value of the line at -2 had to be equal to the y value of this curve at -2, and from there were able to solve for the a value. Okay, that's it for this one.